Hello there, my name is Stian. I'm a design engineer here at CADWorks, and today we're gonna use a 3D scanner to collect data for our individual throttle body uh, intake system on this Porsche 944. And with me here I got the Shining 3D Einstar. This is, in my opinion, the best entry-level 3D scanner. I have had this 3D scanner since it was released in 2022, so I have quite some experience with the Einstar, and I'm really pleased with this. It's actually a very good 3D scanner. But if you need even higher accuracy and more demanding reverse engineering jobs, I would recommend the Einscan H2. And I'm gonna show you here today that the H2 also is a very good tool for mechanical designs and mechanical engineering and reverse engineering. We're gonna use this scanner here today, and we're gonna scan this engine bay here with the engine with texture on, and we're gonna scan this intake here, the intake flange, with a high accuracy. And the hood here, I already have the mesh file for it, so we're just gonna use that. And at the end of the video, we're gonna align all scans. So yes, let's begin. Okay, so we're gonna set up the scan for the engine bay, and for that I'm gonna choose the white light mode. And we're gonna make it a new project, which I'm gonna call engine. And for this scan, I'm gonna choose the feature mode. The H2 is really good at the markerless scanning, so we're gonna check that out. And I'm gonna choose 1 millimeter point distance. That would be sufficient. And texture scan on. Let's just set up the working distance and brightness. Okay, we're all set up. Let's start the scanning. And I want to capture data all along the edge of the front fenders, because I'm going to align the hood later in this project, and also capture the strut towers because I want to have that data when I'm going to design my own strut bars. And for these black components, like the brake booster, I real-time adjust the brightness and it will capture that with no problem. And the engine wiring I also want to capture. And now I'm gonna adjust the brightness down a bit. Even more to capture this, like that. Okay, there we go. And also the front section for alignment of the hood. Okay, so the scanning is done. So let's delete all unnecessary scan data. And just gonna do that real quickly.
Okay, so we have a lot of floating objects here, but I'm not too concerned without on this example, so I think we're good at this point now. So let's just apply those changes and get on with the points cloud. Okay, so here you can see the generated points cloud, and the points cloud is basically just a bunch of vertices with their unique XYZ coordinates. And you can see here, if I zoom in, you can see this model is just built up of all these vertices at 1 millimeters distance. That's because we choose 1 millimeter resolution in the settings. And next up is the mesh the model, and the system will generate these edges between all these vertices to create polygons or triangles. So that's what we're gonna do next. So we just push this, and the mesh settings for this scan, I will choose the unwatertight model because I don't want the system filling in any holes. I just want the scan data to be unmodified. And the recommended parameters looks like to be okay for me, so I just apply. Quite happy with the details. It has all the information that I need in regards to designing the individual throttle bodies out of the cylinder head here. And I'm gonna design the ITBs so it won't conflict with the oil filler neck here and the brake booster located here and here. And I also scanned the strut towers because I'm gonna design my own strut bars for reinforcements. And you see also here that I scanned the edge of the front fenders in the front section here. It's because I'm gonna align the hood later, so I can see so I can get the height, the max height of the ITBs, so it won't conflict with the hood. And let's compare this non-texture with the texture on. And here you see why the H2 is a really good tool for also mechanical designs, because the texture camera on the H2 is very good. It's the best I ever used in all my scaling, and you can see here it also picks up product numbers, it picks up connector types. You can see this is injector connectors, and it also picks up sensor types and also wiring. So this will make when I'm gonna make my own engine management system and wiring for that, I get all the length, both for the main loop, but also for sensors and all sorts of things. So this will give me all the data that I need for several different design stages. So let's just export the files, and I'm just gonna save it as OBJ and STL. So you can see all the free space I have here for the I2Bs. And I have all the parameters for an easy and effective design process. So next up is the scanning of the intake manifold, and we're gonna look into that right now.
Okay, so next up we're gonna scan the OEM intake manifold here, and we're primarily gonna focus on the flange with all the holes for injectors, and also the mountings for the OEM fuel rail, because I want to utilize the OEM features when I'm going to design my own flange, which also gonna connect the custom runners out to the I2Bs. So when you're gonna scan an object like this, you wanna orient it in a way that you either can collect all the data in one scan, or you have to scan it in two projects and align the two scans together. I choose to scan this in one scan. And when you do that, when you're going to scan it in hybrid mode, the scanners always need to detect 4 markers at all time. So when placing out all the markers, you can get quite creative. I have just 3D printed out all these cubes and put markers on them. And we'll keep the tracking the scanners real good with no issues. So yeah, let's just start the scanning.
Okay, so here we are in the Shining 3D software, and we're gonna scan the OEM intake manifold. And for this project, I'm gonna choose the white light mode. And we're gonna choose a new project, which I'm gonna call intake. And for this one, I'm gonna choose the hybrid alignment, and I'm gonna make the resolution 0.5 millimeter and no texture. Okay, so let's start the scanning. how quickly the H2 captures the data. And I'm just gonna orient the scanner to get as much details around the injector holes and the mountings for the fuel rail. Okay, so let's review the scan data here from the intake manifold, and it looks pretty good. Um, and here you can see why I've placed out all these markers in different orientations, because when scanning the object like this, you want to get all of the angles, and you can see here that it's picked up all these markers from the cubes, so it didn't lose tracking. And as always, I wanna delete all unnecessary scan data to make the files easier to work with. So I'm just gonna create a cutting plane by picking out some of the markers, and like that. And I'm just gonna also delete all unnecessary like that. Also these can be deleted. And now I can just do connected domain and invert selection, and it will delete all other scan data. Okay, so I'm pretty happy with that. And let's just generate the points cloud. And here you can see the generated points cloud. And looks like I have all the details that I need. You can see the holes for the injectors here, and the mountings for the fuel rail. I also got all the holes, mounting holes, so that will be bolted down to the cylinder head. I also have the complete flange here, and I'm gonna design my own version. So I'm pretty happy with that, and let's just mesh this model. And for this one, I'm just gonna try this semi-watertight, and the recommended parameters looks like to be good. I want smoothing, I want low, that's for sure. And actually I want to try a medium filter, because I do want some pretty distinctive sharp edges, and that won't conflict in my reverse engineering of this flange. It will be okay. So I'll take medium filter and low on smooth, and the rest looks like to be okay. Okay, so here you see the mesh model layer, and this will be just fine for my needs. It has all the features that I need to design my own intake flange, so I can also model some intake runners out to the I2Bs. And I'm pretty happy with the result. It has all the features that I need. So I will confirm those settings. And I'm thinking about I'm just gonna cut away even more scan data that I don't need. I will do it like this, and I will delete it. Yeah. Okay, I'm happy, and let's just save this as a obj STL file. Okay, so now we have all we need. We have the scan of the engine bay. We have the scan of the intake manifold, the flange and the runners. And we also have a scan of when I previously scanned the hood. So we have all 3 scans, and next up we're gonna align all the scans, and I'm gonna show you how I do it. And okay, so that's next up. As you can see here, all scans are aligned. The intake is aligned to the cylinder head, and the hood is aligned to the engine bay. And also the texture scan. And as you can see here, all scans are aligned. The hood is aligned to the engine bay, and the intake is aligned to the cylinder head. And also the texture scan also is aligned with everything. So we're pretty much ready for export and continue the work in Blender. So here we are in Blender, and I'm gonna import the mesh models. So I go to File, Import, STL, and let's see here. I'm gonna choose the engine first, import. Okay, there we have it. And there we have it. It looks kind of weird, but it's okay. And we're gonna import the intake, import. You can see it all aligned to the cylinder head because I changed the global coordinates. Very good. And let's import also the hood. There we have it. It's all working very good. So let's just select all scans, engine hood intake, and I'm just gonna take Control G like that, and I'm gonna export it as a STL file. Um, and let's check how it looks in Solid Edge. So we are at the last section of the video here, and you can see that I have imported the mesh model that we did in Blender, and you see that Solid Edge import the mesh into several different objects, and most of them are just small floating objects that can be deleted. So what we really need is the engine itself and the chassis, and of course the aligned intake and the hood. And really all the other I can just delete because I don't need it. So we are at the last stage. I have deleted all the unnecessary floating mesh objects, and I only have 4 meshes left: the engine, the chassis, the intake, and the hood. And the nice part about doing it this way is that I have now all the meshes that I need for the entire design process, and I have it in one part project in Solid Edge, which gives me all the reverse engineering and surfacing tools that I need. So example, when I want to start reverse engineering the intake flange, I can just toggle off the other scans, and I can do my design work here, and I can just toggle on the engine bay scans to see for clearances and see what space I can do the design. And you can see here the brake booster is one crucial element. And so also the hood gives me a clear indication of the maximum height I can design the ITBs. So I think this is a pretty good way of working with scan data and getting all the information that I need for an effective and good design process. So that was all, guys, and thank you for watching.